So this tutorial shows you how to download and install VTAS and how to do a very basic simulation. So I'm going to start by assuming that you have no knowledge or have never used VTAS before, so I'll show you how this works. So first off, you have to go to Dropbox.com and grab the file off of the shared folder. So you should have gotten in touch with me and gone into Dropbox and have access to the folder. So the folder here that you should have is this VTAS distribution. Some people, if they really want the code, want all the gross details of what's going on inside, if there's this VTAS code distribution, you can contact me, I'll get you access to that too. So if you go to VTAS distribution, you see there's a number of old versions that are here, and what I'll do is you can download VTAS 3.0 zip. So you can download this right off of the archive here. Now it's 140 megabytes, and I'll show you why here in a minute. I already have it on my computer, so I'm not going to download it here right now for the sake of time. But what you'll get then is, if I go to the file area here, that has 3.0, you're going to get these files here. So these are the files I put into 3.0. There's a manual made out of Microsoft Word, which gives a lot of the details of how to run VTAS. A lot of things I'll go over here right now. There's a number of input decks. We have 1 through 11 here, and the most important thing I want to show you is this README file. So the README file, if you double-click on it, it says that in order to run it, because this was compiled in MATLAB, is you need to install this MATLAB compiler runtime. There's a website here that allows you to download the MCR. So if you go back to, if you copy the web address and you go back to your, I use Firefox, but I think any sort of browser is fine. You can get to the MATLAB compiler runtime. Now if you notice here, there's a number of different versions here, and this one requires R2013A. So you grab this R2013A 8.1 right here and download it and install it. I don't need to do that for this computer since I've already have MATLAB installed. So you would download and install this. It's a free download, and then you would be ready to roll. So what you see here then is there are 2 executables. They both have the MATLAB logo, but they're both .exe files. First one is VTAS.exe. Notice that it's only about 1 megabyte in size. So this is the one that we're going to be running today. One aspect of VTAS that, if you're interested to see how it works, it's more of a proof of principle. It's not a full-blown capability yet, and then we can apply it for any arbitrary data center, is the VTAS POD. This includes that POD, or proper orthogonal decomposition algorithm, that allows you to take detailed CFD data inside a data center and basically wrap it into a smaller data set that you can use for calculating entropy destruction due to airflow recirculation. So we're going to run just the standard VTAS here. And there's 2 ways of doing it. The first way is by double-clicking on this. And if you double-click on it, then it'll spawn the executable. If you give it a minute, and it opens up the screen here. So this is the VTAS opening screen here, where you can create something from scratch, a new simulation. Or you can exit out of it, which I'll do here, and you see you go back to the screen here. Everything goes away. Double click on it again to bring it up. Again, give it a minute. Then you can open an existing file, which we'll do here. I'll show you how that works. The VTAS POD, because it's so much bigger, I know it's 145 times bigger. It's 145 megabytes. It'll take a good minute, maybe 2 minutes for this screen to pop up. So it's just such a massive file because of all the POD data that's ingrained inside that it takes a long time for it to open. So anyway, if you run VTAS, we're going to open an existing file just to show you how it works. And if you notice in the current directory, we have a number of input decks. The only one that you're not able to use with the VTAS.exe instead of VTAS POD.exe is input 10, because that's the POD file. The rest of them are fine. One of the simpler ones is input 1. So if we open it, then it imports the data from that input deck. And what it is a steady state simulation. And I'm just going to hit next to go through all these screens here. A lot of these are not important. Some things that you can see here, like the fans, all these fans were imported into VTAS by reading in that other input deck. And if we go all the way to the end here, You can see there's a large number of windows, and you basically just have to play with the code and get used to what all these mean. Use the manual to help guide you through it. You get to the input check, and so this input check was run very fast, and it didn't find any errors or warnings. So we'll click on Next, and what this is this is the preprocessor's. It provides a layout of the components as well as the pathways. So the blue paths represent water paths, the black represent the air paths, and the solid arrowheads mean that there's a fan or a pump there, and the open arrowheads mean there's not a fan or a pump. So if we continue, then we get to the run window. You can either preprocess only, which means that all it does is create this file infile.txt based on the inputs that you provide through the GUI, and it'll show up here in this directory here in a minute. Or you can click on Go. And if you click on Go, it'll run VTAS, and then at the end here you get the steady state simulation window, where you can look here and you can provide either a plot of the heat exchanger exergy destruction in each of the components. And of course, if you want, you can save the window here as an image if you'd like. So this is one way to run VTAS. Notice that the in file opens up here. So in fact, if I double click on it in Notepad, you can see all the parameters are in here already. Right, it includes a lot of data. So what I'll show you is another way of doing it, which is the way I recommend. If you go to your Windows prompt and you type in CMD for a command window, what you want to do is you want to go to the directory that has VTAS inside of it, where you place the executable. And if we look here at the top, we have VTAS v3.0, VTAS full distrib. Alright, and you can do the dir commands to make sure it's in there, and sure enough, VTAS.exe is in there. So I'll show you, you do the same thing here, although you can run it from the command line, either by running just VTAS, and if you just type in VTAS, of course, you get this. For some reason you get this warning message, but it's not important. It doesn't seem to influence things. So it's one way to run it there. But there's also a number of different command line arguments that you can provide. So one of the most important ones is -help. So if you say that, what will happen here is it'll tell you the various command line arguments. So here you can either say -no GUI, which turns off the GUI preprocessor. If you do that, then you need to specify the name of the input file, or else it'll balk on you. You can turn on or off the post processor by doing plot off. The default is a plot on, or whatever's in the input deck. So you basically overwrite what's in the input deck with that. So what I would do is I'd run the same thing here. So VTAS no GUI -in input 1.txt. And what this would do is it would run VTAS, it would read in input 1.txt, and as you can see here, there's more data that's provided here in the command window than you get if you run it by double-clicking on in your Windows Explorer. And you get to the same point at the end here. So that's a steady state model. And the way VTAS works is you have to first run a steady state model to produce then an output, we call it a dump file or a restart file, and this is out_s right here. So this is a .mat file, which is the binary file that MATLAB uses. And from this acts as a starting point to then doing transient simulations. So what we do now then is you can open up VTAS. We'll do it again here. This time we'll do it with the GUI, and we'll open up then our input1.txt. The default that's in the input1.txt is it's a steady state simulation. Now it's a transient one. We're going to read in the data from out_s map. And now in doing so, it opens up a transient parameters window. We're going to run it for 6 steps with a time step value of 1. And you go through a number of screens again. There's fewer screens because there's fewer options available to you when you have a transit simulation. And then you get to the input check. Again, there's no errors or warnings. It shows you again the layout, and then you can go again. So this time, I have to give it a little bit of patience here, but it'll run the 6 steps, and then we'll have a different post-processor screen. Okay, so the post-processor screen looks similar to the steady-state one, although of course it says VTAS transient solution up here. There's also two different menus. Instead of steady state simulation, it says transient simulation and plot. So for the transient simulation, for each of the two printed time steps, which is an option that you could provide earlier on in the I/O window, you can either give the heat exchange. So at time 0, this is the heat exchange in the components, or at time 6, you can give the heat exchange or energy destruction just like you can at time 0. So this is something that's different than the earlier one. Also, you have this plot, and you can plot either the heat exchange or energy destruction here. So it looks like a blank plot here, but then you can go into and you can plot it each individual component. So you can select, say, the chiller. This will tell you the heat exchange versus time, and say the CRA. The heat exchange versus time. Looks like the plots are right on top of each other. Alright, the cooling tower is going to be a little bit different. So you can see you can add as many components as you want to this, and it'll show you where things are at. Okay, so that's it for the tutorial here on how to install and run VTAS.